Yeah, kind
Just going back to the super there, I was trying to mess around and see if I could use like the super and be, I guess, more um like filter out the different class like attributes, I guess.
of.
But it looked like I have to include every one of the attributes inside of the super method.
Yes.
Does that sound right?
Yes. So you're
Okay.
going to use super if you want the functionality of the super class method as well as extra stuff. If you don't want everything that's in the super class method, you don't use super at all.
That makes a lot of sense.
So
Okay.
you can just redefine your own. Awesome. Any other questions? No. Okay. While we're at a good point here, hopefully things are making sense. I'm just gonna do a quick example of the getters and setters one more time, because you guys asked for it earlier. Okay, so let's say I'm gonna set a name getter and setter because name is something that we were grabbing a lot. So again, we do define name, and then on top of it we say at property, and then here we can just return self.name. So this is the way you create a getter. So again, getter is gonna happen whenever I say, let's say dog here. So if I say print spot.name, this should invoke this getter, because even though this is created in the animal class, name is still a property that I'm able to access as a dog, because animal or dog is a type of animal. So if I'm just gonna do a print in getter. So now, because I am just gonna comment this stuff up, because I'm trying to print out the name. Can't set. Where am I trying to set the name? Line 8. Oh, there we go. Okay. So you can't set the name because we are creating it as a property and we haven't defined the setter. So define name, and then this will take in a new name. And for this, I'm going to say self.name equals n. I didn't change the name to a private one, so we'll see what kind of behavior we're going to get, because this is yeah, this is different. So name dot setter. So this becomes our setter, and we will see what happens. Okay, so we got the line was repeated more than 993 times, and that is because it is somehow recursively going in circles, which is why we want to change the name of this. So even if we just put 1 underscore, so it's not a private one anymore, but it's at least named different than what it is. There we go. So in getter, we were able to get the name down here. And then if I say spot.name equals something, I don't know. What did we use yesterday? Bebo. And then I can just print the name again. Okay, so in getter, prints out spot. And then I did not print out that we're in the setter, but the name changed to Vivo. Yeah, Lewis.
Can you explain what's actually happening like behind the scenes? Like how is this
Yeah, so our getters get called whenever you have instance dot that property name. So up here, I'm actually gonna create this a little closer so we can let's just ignore the inheritance part of this real quick. I'm just gonna create an animal. So I'm gonna say spot equals animal, and then we just need to send it a name. So spot. So whenever I say spot dot name, it will call the getter. It will call the property that we have defined here. So if I'm trying to print it, if I just call this without printing it out, it's going to say in getter because this invoked this method here to run, and this one gets run whenever we do spot dot name equals something. So here I should probably just print out here in setter. There we go. So spot.name will give us access to the property, the attribute, and it will get called when we try to access it, pretty much. And then the setter will only get called when we're trying to assign a value to that attribute. It will know that this is an attribute or this is a property that we have defined. And when we say dot setter, that means this is the method to call when we are trying to assign a value to this attribute.
So you can't have setter without a property, right?
You can't have setter without what? Sorry?
That property, because
Property, yeah. Yeah,
so you have to have both.
If I didn't have this, I guess I might know. So if this was a different name, so if I didn't have a property for name, I wouldn't be able to create a setter for it because I have to access the name property and then add a setter to it, pretty much.
Okay.
Yeah. Nick.
So this functionality right here in this example doesn't seem to be really any different than not having a setter or getter. So would you want to like have them manually call that name setter function if you wanted it to be like intentional that you wanted to change that in that class?
No, you would just want to. So it happens behind the scenes, and when you're not in the class, when you're just using the class and creating instances and stuff, you don't want to have to deal with any specific calls to getters and setters. This allows you to just say this equals this, and it'll handle everything on the back end.
But isn't that the same as not having a setter and a getter?
Yeah, so this part, yes, but what happens on the back end is going to be different if you have different logic. So in this case right here, it is the exact same. But actually, it's not the exact same because these print lines don't happen if I just access it and try to set it. So yeah. Yeah, Luigi.
Can you show us an example of having like two more attributes that needs getters and setters?
Yeah, so for here we have name, and I'll add one for legs. So we would just do the same thing. So define legs self. And we call it a property, or we decorate it with a property decorator. And same thing, we just return self dot legs. But the only thing is we have to, again, change the name of this. So because if this name is the same as this name, it's gonna get confused, and like we saw earlier, it's just gonna go into like an infinite loop pretty much. So yeah, and then same thing for setter. So just do this. So at this one's legs dot setter. And then I am just saying self dot legs equals L, and I have to take in L. Make sense?
Do you have to have the self.legs equal L? Can't you just,
Can I just put legs equal L? Is that what you're asking?
so in the no, for the what is it, the name property?
Mhm.
Or actually the legs property, do you have to have it equal to L, like a parameter? Self._legs equals L.
Yeah, because this is the setter, this is not the getter. So a setter again will be invoked when this happens, right? When we're trying to assign a value to whatever property it is. So if I said spot dot legs equals S, what will happen in the background with the setter is it'll take legs as the name to find. So it's going to try to find a property setter called legs, and then it'll take this as a parameter. Whatever is after the equal sign, it'll take it in as a parameter. That's why we needed to take in a parameter. We can call this anything, obviously. So X, and then we have to assign it to legs because that is the value that we're tracking, right? So up here, because this is what we're getting when we get legs, this is what we should be assigning when we're assigning to legs. Does that make sense? Awesome. Okay, I'm just gonna delete this example, but I'll keep these here. Okay, any other questions? Okay, moving on from getters and setters back to inheritance. Questions about inheritance? That might have come up. No. Okay, let's do this one last part. So so what if we wanted to do multi-inheritance? We were talking about this a little bit earlier. Oh, actually, before I get into that, so earlier we were trying to add a mammal class, right? So if I wanted to say an animal is a type of mammal, can someone tell me why it wasn't working before? Yeah. Maybe Jim, since this was your question, if you can tell us now why it wasn't working to access this attribute.
I don't know why it wouldn't have worked. I was thinking that if you could imagine building a class of animals, vertebrates, mammals, cats, dogs, whatever else you want to do there, that the first one would not have anything in the brackets. The second one would have the class above in its,
Mhm.
and then the third one down would have the class above it. So the first, secondary, and tertiary.
Yeah, and also I know that mammal is a type of animal that they should be switched, but
Yeah.
so can someone take a stab? I think I saw some correct answers in the chat. Does someone wanna say why I wouldn't have been able to access mammal as a dog? Or
I
even as,
believe that you're missing name. It needs to be the same as the child. Child can be more, but your parent has to be the same as the child for the init.
okay.
You need that super on animals.
You do need the super. So what is happening here is we're a class animal, right? But all we're defining in here is name and legs. And since we have an init function here, this is overriding the mammal init function, which sets mammal to true. So what do I have to add here to make it work? For me to be able to access the attribute mammal as an animal or a dog. Super, yeah. So you would need to do super dot init. And this init doesn't take anything, so you don't need to do anything at all. But what this is gonna do, it's going to initialize the mammal attribute. So that way we have access to it in animal. And since dog is a type of animal, it will have the attribute mammal in it. So let me create the dog. So the definition of how we initialize a dog has not changed. We haven't added any variables, we haven't done anything. We just added one more init, so that will just add some attributes to it. So if we say Spot is a dog, and then we want to print out Spot dot mammal. And let's see if this works. And it works. So before I had done the super here, it has no attribute called mammal. I will rename this to is mammal because that is the correct way of naming things. So still has no attribute.
So I don't fully know how we'll use that in the future, but that seems important or really cool in that you can test about a class membership by doing what you just did there.
Yeah, so you can test whether you're creating them correctly. If this is an instance of this and all mammal, or this is kind of a bad example because like I said, mammals type of animal, but let's say all the animals that we're gonna encounter are mammals. So this mammal has information that we would need for all of our animals. Yeah, so if I added one here, we should be able to see it. So self dot adds teeth. I know this is not correct, but let's say it's true. Then if I print this out, I'm not trying to print it out, but so print Spot dot has teeth. There we go.
So that's returning a Boolean there, using that
Mhm.
same technique. Can you roll back down there where we are using that same technique? So you could say has teeth equal, no, equal to false, okay, equal to true. That's, you're already getting a Boolean. Could you do, okay, I see.
Okay,
That's cool. Yep.
awesome. Any other questions? I just wanted to show why that one wasn't working. It's because we needed to invoke the upper level initializer. Okay. Let's see.
I've got one more.
Oh,
actually.
yeah, please.
I was asking, is there a limit to the parent-child chain? And then say that there's not, and you can keep going down. Does super only refer to the direct parent?
Yes,
Okay, cool.
super does refer to direct parents. I don't think that there is a limit. Yeah. I guess the limit would be how complex is your program becoming and how easy is it to use it. Yeah. Okay. So, let's say we have,
Can we go back in there for just a second? Because Samuel just made a good point. He said that it starts to be confusing if you have a generous number of divisions and subdivisions. What is, and I think we touched on this yesterday, what is best practice? Is it wisest then to put your class? So in this instance here, would you likely go to press, write your code just like it is, or would you start splitting out? And how do you subordinate animals, excuse me, cats and dogs in one file on your left over there? So how do you have a class then exist in one file subordinate to week 2, day 1 inheritance? So how do you split these apart as files? Can you have a mammals class and all of its interesting things? And then can you have a different, so you have a mammals underscore class dot py. Then you have a carnivores underscore class dot py that refers back to mammals in the other file. What is the best practice here?
so short answer, first of all, you can have classes in separate files, and depending on your use case, like depending on how many classes you have, how your inheritance would work, you can just create folders. You can create folders and the files can live within folders. So you organize it the way that makes sense to your project and makes sense to access things. So you can have like an animals folder, and if this is your like top one, so you can have an animals folder that has your animals class and all of the stuff that is related to animals, and then you can have a mammals class or mammals folder and have all the stuff in there. You can have different classes that fit within animal. This is all just organization stuff there. I don't think, I mean, I say this a lot. I don't know if there's no specified way that you should do this, but a lot of people on the internet have a lot of opinions on this. So you can probably find opposing opinions on all of it. So it's what makes more sense as you're using it. As you're a programmer, you're going through your code, you're writing it, you will get a feel on what makes sense and what does not with organization. But yeah, so there should be no issues with having different classes in different files. Like I've shown in the last few days, you can just import and use it. So import something from something, or from something, import something, and it will do the job that you want it to do. Okay. Did that answer your question? Yeah. Awesome. Okay, so this last part, we're going to talk about multi-inheritance. So I'm just going to write some code. So I'm going to import math, just because it's going to be used in this example. So I'm going to create a person class. I'm actually just gonna copy it from my example here because it's faster. So here, our initialization, it takes a name and it takes a job. And when we want to say person.work, then that person will be working as hard as they can at, I don't know. Okay, so we have a person class, and let's say we also have a computer class. So this computer takes in number of cores and it computes something. So it just a random thing. It computes round, I think, is number given for, yeah, it just rounds the number for pi and number of cores. I don't know, it does something, some math thing. This is not important.
Pi to the number of cores.
It rounds what?
It rounds pi to the number.
The number of cores, okay.
The digits.
Ah, thank you, thank you. I've forgotten how to use that because I haven't used it in a while. Okay, so let's say toaster is computer, is of type computer. And number of cores, say it's 4. So if I say toaster.compute should give me I'm running the wrong file. Okay, so it gave me pi rounded to the 4 digits. So if I change this to 6, it adds a few more digits. So let's say I want to create a class cyborg. Okay. So this cyborg is going to be both a person and a computer. So what this will do, it will inherit from both person and computer here. So obviously with the init function, like which one gets called. So we are going to define our own. And so we can get the values from each. So we're gonna need to grab self. We have a name and a job for the person, and then we also have number of cores for our computer. So like we saw above, or in the other example with using self, here if we use self, it will, sorry, I keep saying self, super. So here if we call super, there's an order in which it takes these. So we can talk about that after. So so instead of starting with that example, I'm just gonna start with the other way of doing it. So you can say person dot init, and you would have to send in self, name, and job. And for this one, or like for the cyborg or the computer part, we just call our computer class dot init, and we also have to send in self here, self, and number of cores. And this should initialize a cyborg that both has person attributes and computer attributes. And then yeah, this is enough for now. So let's say Terminator is a cyborg, and There's Arnold. Job is Terminator. Let's say he has 16 cores. So now we can print out Terminator dot name. We can also print out Terminator dot job and number of cores. And all of them should be there. There we go. So it was able to access all of the attributes that we wanted within this one class. And if we added a function here to override work, wait, let's not do this actually. This example. Question, Cameron.
Could you just use super instead of like doing person and computer?
Yeah, so let's try doing that. So super dot let's do init. So for here, it's going to take the first, it's going to take them in order pretty much. So it'll take name and job here, which IDEs like this help you kind of understand what's happening. And then if we do super again, it should, it does not. There are some resources about resolution order and how things get resolved in what order for this. I think maybe if I send in computer, I think this might work. Computer takes number of cores. I am not sure if this will actually work. Must be type. Maybe type of computer. No. Yeah, so when you have multiple inheritance, it will do some weird things. So it's taking this first one, and it's not really letting me do the second one. There are, let me see the resources here. So I don't want to, please. No. Why? I just opened it earlier. Okay, that's stupid. I will get back to this. Hopefully you guys won't have that pop up. But this is method resolution order, and it will go through the examples of how methods get resolved in the cases of multi-inheritance. So if you have CBA, it will go C and then B and then into A. And then it has a lot of different examples for different types of inheritance. But yeah, I tried to do some Googling. I have some articles. I didn't get a chance to fully read them and get all the answers that I wanted before class. But I will share them with you and we'll kind of explore that. But yeah, questions?
In the meantime, can we just do what you did in line 25 and 26? Just
Mhm.
for like, if we can't get a good grasp of this, that's a safe way to do it. Just 25 and 26 if we want to
Yeah.
inherit from person and computer.
Exactly. So if I wanted to override one of the methods, I would just rewrite it. So define work. Let's forget the self. And for, let's say, self dot number of cores. Or in range of number of cores. I know you guys know what this does, but what does it do? If anyone can tell me, just a refresher.
It's going
It'll
to
just loop through.
basically- it's just going
Go
to go
ahead.
through 0 to it's exclusive, so you're actually going to have one less number of cores than it actually has, but it's just going to iterate through, or it's going to create a range from 0 to the number of cores.
Awesome, and then it's just gonna loop through those numbers. So technically, like if my number of cores was 8, it technically creates 8 numbers, but because it starts at 0, it's going to start at stop at 7. Just wanted to mention that. So in this example that I see here, it's person dot work and sending self. So I'm guessing this is just calling the work function. So this is how you can use, so instead of super, we're just going to be using the actual class name for here, and we have to send in self. So here, the way what I did, I overrode work. So for each core, I'm going to print out the person work sentence. So if I say terminator.work, it's just going to print it out 16 times. There we go. So yeah, I think the consensus is with multi-inheritance, you want to use the actual class name, just because it could get pretty messy with having multiple ones. But if there's only one inherited class, then you can just use self, and it makes it a little easier. But with both, like I said earlier, you can use both. Questions?
Can you do that kind of combination? Like, can you have a function that creates a new class that took like 2 previous classes as parameters to create the new subclass?
I don't see why not. So you're saying like, define, create something, I don't know. And in here, we have maybe like a bug class and something else. So if you want to create the class, you wouldn't need to really pull it in, because if it's defined either in the same file or you import it from outside, you can just say bug and initialize it. So maybe your cyborg has a bug companion for some reason. So you can say self dot bug equals bug. I just need to create that class somewhere. So if I say class, I don't know where that came from. So class bug, and then self dot okay. So the class was predefined. So from here you can just create an instance of this, and it doesn't matter where you are. So Terminator dot create something, and then I can try so this shouldn't work before I actually create it, but let's see what it does. Yeah, so there's no attribute bug in the beginning, but if we run it again, prints out George.
I think my line of thinking is more, I guess, along the lines of having the user have input over what was created. So if I have a set number of attributes or whatever, they could create something that would have its own class. And the instances of those classes, I don't want around all the time, but the class that they created, I would want them to be able to access again later. So in that instance, you would need them to be able, I guess, to create their class and have it stored for reuse later. Is something like that, like, I guess theoretically possible? This is kind of,
Yeah, I guess that would just be a regular class. So classes, you can just define them and then use them wherever in your code. You can use them within other classes, you can use them in regular class. Unless you're saying you're creating an instance of a class and you want that to be passed around.
I
Or
was
used.
more saying that the attributes of the class are not yet defined by the program, but defined by the user. So then it would be needed to be created on the spot.
Uh-huh.
As
Yeah,
opposed to being predefined.
yeah, so if you just define a class and you have all your attributes be defined in an init function, that's pretty much what that's doing. It's this is going to be your blueprint for this class, and the user, when they want to create a bug, they will have to put the parameters that will create that specific instance of that thing. Yeah, does it make, I don't know, did I hit on the
I think so. I think the idea that I relate everything to like a game that I've had an experience in the past to kind of consolidate what I'm learning and kind of cement it. So I was thinking of something along the lines of Spore, where what you're creating hasn't even been created in the game yet at all. You're going to get a brand new combination, and that creature might die or might not always be around, but you want that blueprint that was created. So on the back end, it's not there yet. It's created kind of on the fly.
So you're creating classes on the fly kind of thing?
Yes.
Okay. That is a bigger question, and we should, yeah.
That's fine. Thank you.
No problem. Yeah, Thomas.
Hey, so I saw this on Stack Overflow. I was just hoping we could maybe try it out. So the on lines 30 and 31, I think, the super inits, or 31, 32.
Yeah.
So they were saying for that first one, basically, I guess the way they explained it was that super init does all the constructors for person.
Mhm.
And then for that second one, so on line 33,
Mhm.
they passed in our instance, it would be, they passed in person, comma, self inside of the super parentheses.
Oh, okay. So let me uncomment these. Let's test it out. So for the second one?
Yeah, so they put in person and then comma self.
Okay.
And then supposedly that worked for the
let's try it out. Oh, it worked. No errors.
Excellent. Yeah, they were saying something, basically the first one goes all the way through the constructors of that first parent class, and then the
Oh.
second one you have to specify what the that you went through it, I guess. But
Thank you. That's very helpful.
Hmm.
So yeah, this is a way to use super. But yeah, so it comes down to preference, whether you think this one is easier or this one is easier. Other questions?
So doing that super that way would just help us understand, like when you see that, like say we didn't write this code and we just seen it, we'd be like, oh, this is a super class. Like that's what, I mean, other than that, I don't see the reason to even use a super in this instance, right?
Yeah, you don't really have to. This works completely fine.
Okay.
Other questions?